It's Christmastime in the cosmos. Astronomers have a long tradition of finding holiday cheer in outer space. For astronomers peering into the depths of the universe, Christmas came a little early this year. Using data from the James Webb Space Telescope, NASA released an image last month of a Christmas tree galaxy cluster, a winking collection of galaxies 4.3 billion light-years from Earth. And last week, an image of Cassiopeia A, the remains of a star that exploded 340 years ago, was also unveiled by the First Lady, Jill Biden, as part of a new White House Advent calendar. These images and others follow a long tradition of astronomers and other stargazers connecting the season of light with cosmic phenomena occurring light years from Earth. But there is genuine scientific wonder involved in some of these festive observations. Underlying the Christmas tree galaxy cluster was a detection by astronomers of 14 stars that flicker over days or months, like the lights on a Christmas tree. Seeing an individual star in a faraway galaxy is a big deal, said Haojing Yan, an astronomer at the University of Missouri who led the study. Almost like a miracle, he added. It's not the first time distant stars have been detected, but it used to be a rare treat. With Webb, this has become routine, said Rogier Windhorst, an astronomer at Arizona State University who was involved in the discovery. The observations are possible because of layers of gravitational lensing, an effect by which the gravity of structures in the universe distorts and magnifies the light of objects in the background, making them visible to astronomers. The flickering of the stars is a result of those lenses moving in and out of focus. Dr. Windhorst notes that Earth and the Sun are about as old as the light arriving from this twinkling cluster, which, at the time that light was emitted, was already 9 billion years old. Data about such distant stars helps astronomers compare the makeup of ancient galactic neighborhoods with those that are nearer to us, and how our solar system fits into what drive. Windhorst calls the cosmic circle. Unlike the Christmas tree galaxy cluster, Cassiopeia A is a lot closer to home. Scientists have long studied the violent stellar explosion and others like it to figure out their role in cosmic evolution. Your free account gives you access to many of our newsletters. They help galaxies grow. Danny Milosavljevic, an astrophysicist at Purdue University who studies Cassiopeia A, wrote in an email. Supernova remnants also create the elements needed to sustain life, like the oxygen we breathe, the iron in our blood, the calcium in our bones, he added. At 11,000 light-years from Earth, Cassiopeia A has been observed by a variety of space telescopes in visible, X-ray and infrared wavelengths. But the Webb's new infrared vision affords a better view. In April, NASA released an image of the supernova remnant using the telescope's mid-infrared instrument. The latest snapshot makes use of the Webb's near-infrared camera, which captured gas, dust and molecules radiating at warmer temperatures. The pink and orange structures, enveloped in smoky material against a glittering backdrop of stars, resemble an ornament hanging from a tree branch. 2 years ago, Webb launched flawlessly on Christmas morning, Drive. Milosavljevic said, "At the time I thought it was the best Christmas gift ever. But the telescope," he added, "is the gift that keeps giving." Long before the Webb launched, astronomers often found seasonal spirit in space. In 2008, the European Southern Observatory shared an image of a cluster of stars resembling the sparkling trinkets you might put on a Christmas tree. Captured by La Silla Observatory in Chile, the cluster is scattered among crimson clouds of gas. At the bottom of the image is the aptly named Cone Nebula, a star-forming region about 2,500 light-years from Earth. The Hubble Space Telescope from NASA has also spread the holiday cheer. In 2010, the space agency released an image of a red bubble that looked like an ornament floating amid the stars. That bubble is gas blasted away at millions of miles an hour by a supernova. Astronomers think the explosion was triggered by a white dwarf, the core of a star that has run out of fuel, gorging on material from a neighboring star. 1 year later, the Hubble dropped a breathtaking image of a cosmic snow angel, a star in our galaxy flanked by wispy blue wings of hot gas. Nestled inside a stellar nursery, this region is home to hundreds of brown dwarfs, objects that don't accrete enough material to form into a star. Even the cosmos is wishing you a happy holidays. NASA's Webb, Hubble combined to create most colorful view of universe. The result, a vivid landscape of galaxies along with more than a dozen newfound, time-varying objects. When two flagship observatories unite, they reveal a wealth of new details only possible through their combined power. Webb and Hubble have joined forces to study the galaxy cluster MAX 0416, located about 4.3 billion light-years from Earth. Their combined data yields a prismatic panorama of blues and reds, colors that give clues to the distances of the galaxies. While the image itself is stunning, researchers are already using these observations to fuel new scientific discoveries, including the identification of gravitationally magnified supernovae and otherwise invisible, ordinary stars. MAX 0416, Hubble AX and WFC3+ Webb NIR CAM image. A field of galaxies on the black background of space. In the middle, stretching from left to right, is a collection of dozens of yellowish spiral and elliptical galaxies that form a foreground galaxy cluster. Among them are distorted linear features, which mostly appear to follow invisible concentric circles curving around the center of the image. Full article. NASA's James Webb Space Telescope and Hubble Space Telescope have united to study an expansive galaxy cluster known as MAX 0416. The resulting panchromatic image combines visible and infrared light to assemble one of the most comprehensive views of the universe ever taken. Located about 4.3 billion light-years from Earth, MAX 0416 is a pair of colliding galaxy clusters that will eventually combine to form an even bigger cluster. The image reveals a wealth of details that are only possible by combining the power of both space telescopes. It includes a bounty of galaxies outside the cluster and a sprinkling of sources that vary over time, likely due to gravitational lensing, the distortion and amplification of light from distant background sources. This cluster was the first of a set of unprecedented, super-deep views of the universe from an ambitious, collaborative Hubble program called the Frontier Fields, inaugurated in 2014. Hubble pioneered the search for some of the intrinsically faintest and youngest galaxies ever detected. Webb's infrared view significantly bolsters this deep look by going even farther into the early universe with its infrared vision. "We are building on Hubble's legacy by pushing to greater distances and fainter objects," said Rogier Windhorst of Arizona State University, principal investigator of the PEARLS program, Prime Extragalactic Areas for Reionization and Lensing Science, which took the Webb observations. What the colors mean. To make the image, in general the shortest wavelengths of light were color-coded blue, the longest wavelengths red, and intermediate wavelengths green. The broad range of wavelengths, from 0.4 to 5 microns, yields a particularly vivid landscape of galaxies. Those colors give clues to galaxy distances. The bluest galaxies are relatively nearby and often show intense star formation, as best detected by Hubble, while the redder galaxies tend to be more distant as detected by Webb. Some galaxies also appear very red because they contain copious amounts of cosmic dust that tends to absorb bluer colors of starlight. The whole picture doesn't become clear until you combine Webb data with Hubble data, said Windhorst. Christmas Tree Galaxy Cluster. While the new Webb observations contribute to this aesthetic view, they were taken for a specific scientific purpose. The research team combined their 3 epochs of observations, each taken weeks apart, with a 4th epoch from the CANUCS, Canadian NIRISS Unbiased Cluster Survey, research team. The goal was to search for objects varying in observed brightness over time, known as transients. They identified 14 such transients across the field of view. 12 of those transients were located in 3 galaxies that are highly magnified by gravitational lensing, and are likely to be individual stars or multiple star systems that are briefly very highly magnified. The remaining 2 transients are within more moderately magnified background galaxies and are likely to be supernovae. We're calling MAX 0416 the Christmas tree galaxy cluster, both because it's so colorful and because of these flickering lights we find within it. "We can see transients everywhere," said Haojing Yan of the University of Missouri in Columbia, lead author of one paper describing the scientific results. Finding so many transients with observations spanning a relatively short time frame suggests that astronomers could find many additional transients in this cluster and others like it through regular monitoring with Webb. A kaiju star. Among the transients the team identified, one stood out in particular. Located in a galaxy that existed about 3 billion years after the Big Bang, it is magnified by a factor of at least 4,000. The team nicknamed the star system Mothra, in a nod to its monster nature, being both extremely bright and extremely magnified. It joins another lensed star the researchers previously identified that they nicknamed Godzilla. Both Godzilla and Mothra are giant monsters known as kaiju in Japanese cinema. Interestingly, Mothra is also visible in the Hubble observations that were taken 9 years previously. This is unusual, because a very specific alignment between the foreground galaxy cluster and the background star is needed to magnify a star so greatly. The mutual motions of the star and the cluster should have eventually eliminated that alignment. The most likely explanation is that there is an additional object within the foreground cluster that is adding more magnification. The team was able to constrain its mass to be between 10,000 and 1 million times the mass of our Sun. The exact nature of this so-called milli-lens, however, remains unknown. The most likely explanation is a globular star cluster that's too faint for Webb to see directly, stated José Diego of the Instituto de Física de Cantabria in Spain, lead author of the paper detailing the finding. But we don't know the true nature of this additional lens yet.